So in the last issue, we have seen the consequence of switching to user mode from kernel mode when the IRQL is higher, and we looked at a couple of details of it. Also, we have seen the bug check. Now let's see the next issue in the not my fault. The system is restarting. Starting not my fault. And this time we are going to have the stack overflow. That is the next one. We clicked crash. Broken into the debugger. Again, no surprise, bang analyze -v. This issue I'm assuming to be pretty straightforward, so it is stack overflow. We have seen multiple times user mode, kernel mode, exception double fault, which is the clear indication of stack overflow. It is pretty much giving a lot of details here in the screen itself, even before the bang analyze -v is finished. You can read about it, but pretty much a lot of information is already there. Whenever we see the word double fault, that means it is a stack overflow. The bang analyze -v has returned. It is clearly giving us commands and a lot more information about what's happening. It is asking us to use the kf command. We already know the kf command, which will give us the stack usage frame wise. And bang stack usage, we have not seen this command, but similar to kf. Pretty much from the bang analyze -v itself, we are getting everything we need. Going with the kf command, so I'm going to click on the kf to show you the output of kf command. On the top right here, we can see there is a weird stack usage from one of the frames. That itself is pointing to problem 36C64DB4, so that is pretty high value, and that is from myfault.sys, no surprise. This is the frame which is of interest here. Just want to click on the bang stack usage. It gives pretty much the size of the stack used to buy different modules and stuff like that. We can use the .tss command to get the exact point where the crash happened. It is .tss as per bang analyze -v. It is a task gate instead of trap because it's a double fault. If you look at the value of ESP is similar value or same value as the stack limit. ESP is pretty much overrunning stack limit. We have seen using the bang thread command to see the stack limit. Stack limit is BD76900, which is the same value as the ESP BD76900. Stack limit has reached. ESP is pointing to the stack limit, which is pointing to the problem we are facing here. So that is all I wanted to talk about stack overflow. It is pretty straightforward generally, but there is something I wanted to tell you in a real world scenario when I was facing stack overflow. In kernel mode, there will be a lot of drivers and all of them will be stacked one over the other. The usage of stack by one of those drivers will be genuine or minimal, but there are a lot of drivers like that, especially on the file system, filter stack, etc. Lot many filters using stack memory. Now in this case, you won't be able to pinpoint to a particular driver. In that case, you may have to go with the strategy of which driver you have control code for, and from where you can call ke expand stack and call out. So that is the solution for it. The stack memory size in kernel mode is pretty minimal, so that is why this problem is more frequent in kernel mode. But all this analysis and commands will work, and you need to find out who is using the stack mostly, and you need to pinpoint to that driver. Being said that, let's go into the next issue we are interested in the not my fault.